Hi guys, welcome to HSC Chemistry and the production of materials topic. We're looking at ethanol, and in this particular video we're going to look at ethanol's properties that make it a versatile solvent. If you remember, in the previous video we had a look at ethanol and three of its important uses. One of those was its ability to be converted chemically into ethene or ethylene. The second was its importance as a solvent. And that's the subject of this particular video. And one of the main reasons that we wanted to have a look at ethanol is because of the fact that it is used as a solvent in a lot of very common types of mixtures. And they include things like perfumes or dyes, and a lot of pharmaceuticals as well. Medicines, cough mixtures and things can often contain small amounts of ethanol that just improve the solubility of some of the active ingredients, which are not as readily soluble in water. But the question is, why is ethanol such a good solvent? Now, hopefully you will remember, particularly from the water topic, what it is that allows certain substances to dissolve in others and what means that they won't. The simplest version of that we've looked at before is that like dissolves like. And that's a good general rule to keep in mind as we go through these, because it's a nice general way of remembering that polar substances dissolve in other polar solvents, and non-polar substances will dissolve in non-polar substances. But it's a little bit more complicated than that, and that's why we want to have a look at ethanol in a little bit more detail. The key, of course, is the intermolecular forces. Now, there are three types of these: hydrogen bonds, dipole-dipole, and also dispersion forces. And these are the ones that we want to have a look at in a little bit of detail in order for us to understand them better. If two liquids are going to be mutually soluble, or we will say they are miscible, they will mix together equally, then there must be a high degree of intermolecular attraction between them. Now, this can be dispersion forces between the two different molecules, or it can be hydrogen bonds or dipole-dipole interactions. And this is what we need to look at in a little bit more detail. So, put simply, I guess, if you put oil and water together, they will not mix. They are immiscible. And this is because the oil consists primarily of carbon and carbon-hydrogen bonds. Now, these are non-polar bonds. And as a result of the fact that they are non-polar bonds, they will not interact with the polar bonds within the water molecule. The water molecules themselves are held together by hydrogen bonds. But these are not dispersion forces, and therefore there's no interaction between the water molecules and the molecules in the oil. And as a result, these are immiscible. They will not mix together. So the combination of non-polar dispersion forces and polar hydrogen bonding are two things that are not similar, and because like dissolves like, hence these two will not mix. However, when we look at ethanol, we have something quite unusual in that we have, when we focus in on the sort of body of the structure itself, we can see we've got carbon-carbon bonds, we've got carbon-hydrogen bonds, and we've also got the carbon-oxygen bond and the oxygen-hydrogen bond. So these ones here are going to be very important, as is this region of the molecule here. This part is the non-polar part. A CH3, CH2 has only carbon-carbon bonds or carbon-hydrogen bonds, and these are both non-polar. However, the OH bond we know, as we've experienced before with water, is polar. So that means that this particular molecule has both a polar and a non-polar end. And that means that it is outstanding in dissolving both polar substances as well as non-polar substances. And that is one of the reasons it is an extremely good solvent. So I guess just a quick review then, the conditions necessary for hydrogen bonding. Firstly, we need to make sure that there is polarity. We need to make sure that that polarity is a consequence of hydrogens bonding to either a fluorine, an oxygen, or a nitrogen. And of course, in this case, it is an oxygen, so that's good. There needs to be a free electron pair on another fluorine, oxygen, or nitrogen. So if we remember our electron dot diagrams, the oxygens will actually have two unbonded electron pairs. And that's one of the things that's very important because that creates that region of negativity. In addition to the fact that the differences in electronegativity also draw the electrons closer in towards the oxygen atom itself. Now that sort of thing would happen generally anyway, but the fact that we can actually find these unbonded electron pairs sitting somewhere in this molecule allows for that interaction here, which is our hydrogen bond. Now, when ethanol is dissolved in polar substances, you get this interaction with the hydrogen bonding. So you get a link between, here is the OH bond, and we have hydrogen bonding occurring here and here with our simplest substance that demonstrates this property, which of course is water. And therefore we know that ethanol is soluble in water. Each of the ethanol molecules has two hydrogen bonding opportunities, and you can see where they are, one off the hydrogen and one off the oxygen. And therefore, ethanol will be soluble in other polar compounds due to these dipole-dipole interactions and the specific examples of hydrogen bonds in this case. But ethanol also has this property of being able to dissolve non-polar substances as well. Now in this case, this is, if I just change this around a little bit, so over here, this region here is not going to be involved this time. In fact, it's the rest of the molecule that is critical to the process this time, because it's from here we're going to get these dispersion forces, these interactions between the non-polar molecules and the non-polar region of the ethanol molecules. So therefore, ethanol will also dissolve in iodine and in short hydrocarbons like heptane and pentane, but it will also itself be a useful solvent for the dissolution of other non-polar substances.